Hello everyone, let's talk about cell phone triangulation. So we're doing all this law, sines, and cosine stuff, and now what we're going to do is see if we can kind of talk about some of the ways that some of these things get used, and how really you're being tracked at all times by your cell phone, and this is part of the way they do it. So this says that we're going to do a little bit of forensic cell phone evidence. We're going to basically try and work backwards and figure out where people were, and you guys are going to do a little bit of a mystery thing, figure out who robbed the mall or something like that. So let's see if we can practice drawing things with a protractor. You do need a protractor for this. And then once we build the triangles, we'll be able to kind of actually solve them. So the first thing it says is at time 1. So for this one, I've labeled this as time 1 right here. The suspect was 7.68 miles from Tower B. So I'll draw that, Tower B. This is 7.68. And then it says they were 23 degrees north of west. Now, these bearing directions are kind of tricky. When it says north of west, what that means you need to do is you need to stand here at Tower B and you need to look west. When it says north of west, you want to look west, and then you're going to go from that direction, from looking west, you're going to then go up. So the angle that they are talking about is the one that's formed with this guy. This angle is 23 degrees. Now, we're talking about the cell phone tower A and the cell phone tower B, and here is where the person was, so you can see that there's a triangle. And in the directions, it says that this one's at negative 10, 0, and this is at positive 10, 0, which means this whole length would be 20. So you'll notice we have a triangle here that's SAS, and I'm actually going to take this triangle, and I'm going to reference it again later, so I'm just going to kind of make a copy and put it off to the side, because I'm going to need that in a little while. So I got one of the triangles there. And now the next thing says at time 2, so I'll do this one in red, the suspect was 7.28 miles from Tower A and 19.2 miles from Tower B. So this is 7.28 and this is 19.28. And then I'll draw this just so I have it right there. That is 20, again, for the same reason it was before. And I'm going to see if I can just take, can I just get the red one, I wonder? How am I going to do this? I will. Let's see. Let's copy this. Let's take these guys. Just that. That'll do it. Okay. So there's my other triangle. Just put that off to the side. I'll even throw that extra side in there too. Cool. I'm going to need to analyze these triangles in a sec. But for that one, you'll notice we have side, side, side. So my two triangles are right there. And once we've got the things labeled, now I'm going to be able to actually answer the questions like how far were they, what are the missing angles, missing sides. So the first question says, how far was the suspect from Tower A at 9:12? So remember, 9:12 is time 1, so we're talking about the yellow graph. How far was the suspect from Tower A? So that's this distance right there. So that's this distance, that's what I'm trying to find. I'll call that X, and we'll go ahead and find X. Now, you need to know what information you have. You have side, angle, side. Side, angle, side means you need to use law of cosines. So law of cosines, since we have this angle, I'm going to say like x squared equals, now remember it's the other two sides, so 20 squared plus 7.68 squared minus 2 times those sides. And then you need the cosine of the included angle, which is 23 degrees. So this is very much just type it in the calculator. 20 squared plus 7.68 squared minus 2 times 20 times 7.68 times the cosine of 23. And that's the squared. So to find x, I will square root that and get 13.27. So x equals 13.27, which means the person was 13.27 miles from Tower A at time 1. So this is 13.27. And these are miles. Okay, so first thing, they were 13.27 away. And now the second question, where is the second question? I know there's another part to this. Is that on the next slide? Okay. Well, there is another part, and I'll type it out because I don't know why it's gone. It says, determine the location of the phone from Tower B at 10:35 in terms of its angle. Okay, so there's the other question that you guys have. Let me make sure I do that so you can see how that works. Because this is one of those bearing things again. So from tower B at 1035 is time 2, and tower B is off to the right. So I want to know the location of the phone from tower B in terms of its angle. So I want to know this angle. And to find that angle, I have side, side, side here. So side, 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 I'm going to use law of cosines, and I'll call this just theta. And I'm going to say theta equals, let's see, to do this, I'm going to have to write out the equation. This is going to be a little annoying. 7.28 squared equals 20 squared plus 19.28 squared minus 2 times 20, 19.28. And then this is the cosine of theta. So remember, the cosine of the angle that you're trying to find is always going to be opposite of the side. So in the formula, if you're going to use like this is your a squared, then you're solving for a. Type it in. Now remember, when you type this in, it's kind of tricky. You need to first subtract your squared terms, so 7.28 squared, and then minus 20 squared, and minus 19.28 squared. And then you need to divide by this product, which is the negative 2 times the 20, all that. But you need to put in parentheses, otherwise it won't work. Negative 2 times 20 times 19.28. And remember, this is the cosine of theta. If you want to find theta, you need to do inverse cosine. And inverse cosine will tell you it's 21.3 degrees. Theta is 21.3 degrees. So that's 21.3 degrees. And now, to say that in terms of bearing can be kind of weird. But what I want you to imagine is, which direction would you want to look? If you were at tower B, you would look west, and then you would say, I want to go below that. So cardinal directions, we'd say we're going down, we're going south. We're going south of west. So this is 21 degree, we'll say 21.3 degrees south of west, which means you look west and then you go south. South of west means you look west, and then from there you go south 21.3 degrees. So south would be down if west is left. Okay, that's the first one. Now the back is very similar, but on the back I don't give you the points, so you need to actually use a protractor and draw it. So this is a little bit fancier. Let's see if we can look at the back. I need to take a protractor. I do need one for this part. So you'll notice I have the dots, so you can kind of figure out where they're going to be, but I want to practice measuring the angles. So the first one says at 258, so we don't know which one 258 is. The suspect was 12 meters from Tower A and 48.6 degrees west of south. So I'm going to look at Tower A, and I'm going to say west of south. To do that, I'm going to take my protractor, and I'm going to move it vertical, like this. That's now running north-south. Okay, if you imagine that's sort of running north-south, and I'm going to put the center here at Tower A. If I want to measure 48.6 degrees west of south, imagine I'm looking down, which is south, and then I want to go west of that. So I'm going to go this way. So this angle that's being formed, whatever this angle is, needs to be, how many was it? 48.6, which isn't going to be perfect. Let's just say about 49 on here. I think I can measure that pretty well. Let's see. Hey. Okay, so it's kind of going the other way, so I'd have to do 180 minus 49 to use this thing. So 180 minus 49 is 131. Let's find 131. There's 130-ish. Okay, so right about there. We said it was, how many? 48.6? Okay, so if I actually do 180 minus 48.6, I get a little, I can get the decimal even more exact. Might as well. So 131.4. There you go. Okay, so you can see this is sort of our angle that we're going to work on. I think we can all see we're going to be in the dust collectors, but we also need to figure out that distance, and to do that, the easiest thing to do is just kind of use any tool that you have. Like if you have a protractor, I'll try and use a ruler on here. I have a ruler. You're just trying to figure out how far that distance is. If it says that we are 12 meters, look on here and realize that this is -10 and this is +10. So 12 meters is about 5.5 or whatever these units are. So if I look and I take my ruler and I measure 5.5, it should be about 5.5. See? Right about there. So you can see that this is my first spot. Now, if you don't have that dot there, this can be a little bit trickier, and you're going to have to actually measure that out, because otherwise you don't know if you're in maybe dust collectors, or if it was shorter, you might be in Stacy's, or off the page wouldn't be good, but you do have to be careful with this. You have to be precise, because it's going to ask you what location things are in. So there's the first thing. Now what else do we know? That's just the first time, so we know they were at 2:58. So maybe I can mark the time, 2:58. Whoa, 2:58. That's where they were. And I will also fill in what I know here because I'm going to need this triangle. So I'm going to kind of draw it and label what I have. 48.6 degree west of south, and that's 12. So 12, and this is 48.6 degrees. So there's my first triangle. I'm going to group all that up and just leave it there for now. Okay, one down. Now let's do the other two. It says at 3:12, they were 19.2 degrees west of south from tower A. So again, west of south means I'm going to take my protractor and I'm going to make it run north-south like this. And I'm going to put the spot here because that's where my angle is going to be from. And now it's 19.2 degrees. So I'll do 180 minus 19.2 just because my protractor, 160.8. And I'm going to now measure this at, go back, at 160.8 because that is what I need if I go this way. Okay, it's about like that. That's pretty close. So I'll do this one in red. Like that, you can see again, we're going to be in swag. So I'll draw this because I know I'm going to need that. And then it also says that we're 19.5 degrees north of west. So let's see if we're close. Oh, I can reset this. If I put this here and I say, how many degrees is that? We're supposed to be 19.5 degrees north of west. So if I go west, this is west, 19.5 degrees above that should be right here. I wish I could measure that, but if you do 180 minus 19.5, you can see that this is 160.5, which is right about there. You can see that it's pretty close to where I have my dot. So the fact that it's 19.5 degrees, you got to realize that's north of west. So this is 19.5 degrees, this angle right here. I probably actually want this angle on the inside. So I'm going to just do 90 minus 19.5 and get that angle, which is 70.5, because that's actually what I'm going to need. So I'm going to label this as 70.5 degrees on the inside. And if I have two of the angles, remember this one we said was 19.2 degrees, then I can really find the third by subtracting from 180. So I'll do 180 minus 70.5 minus 19.2 and get the missing angle here is 90.3. So this angle is 90.3, and I also know that this distance has got to be 20. So I have a good amount of information on this red triangle, and I know it's 20 because look, it says 0, 10, this is 0, 10, this is 0, negative 10. Now let's get that guy out of the way because I'm going to need to solve him. Okay, and there's my second triangle. I know that my second time is in swag. One more. This one says we're going to go, we're 10 meters from tower A. So if I have tower A and I measure 10 meters, I'm going to guess that's about 10 meters. And tower B, it says we are 29.7 degrees east of north. So let's try that. 29.7 degrees east of north means I'm first going to run my protractor north-south, and I'm going to measure 29.7 degrees east, which means I'm going to go to the right 29.7 degrees, which again, I got to do 180 minus 29.7, which is 150. So 150.3 is about, yeah, it's about there. There you go. So you can see that's my angle, and I'm not perfectly vertical, I think, so that's why it's a teeny bit off. But that is the angle that we're talking about. This is 29.7 degrees. And what else do we know? This length is 10. And we also know then also that the distance is 20 here. So that's 20. Now, if I look at that, I'm just kind of eyeballing it and saying, look, that's angle side side. Better be careful on that one. Okay. But the idea now is I have my three triangles. And from here on out, all the questions that I answer are just going to be about these three triangles. So I can have them on here, but it kind of gets a little bit messy. That's why I think it helps to redraw them. Now we're going to actually answer some questions about these three triangles. So let's just take them, and I will put them on the next page because I'm going to need them on the next page. So let's take these three triangles. Can I do this? And we'll do copy. Come on. Copy, and then we will paste them on here so I can reference them. Okay. So remember, the first one is we know our time. was 258, and that was, let's see if I can put these back on here. There you go. There you go. 258 was the yellow one, and we were in the dust collector. So the first question is, where were we? We were in the dust collectors. The second one, at 312, we were down here in swag. And then the third one at 355, we were over here in infamous footwear. Cool. So first thing it says, how far was the suspect from Tower B at 258? So 258, they were in the dust collectors. So 258 dust collectors, that's this yellow one. And it says, how far were they from Tower B? So Tower B is, that's Tower B. I can't see it. This is Tower B down here. That's a B. How far were they from Tower B? So we're trying to figure out the distance here. So the unknown is this distance. That's our X. And what information do we have? We know this is 20 again. And we have side angle side. All right, let's use law of cosines. And to find this guy, I'm going to say x squared equals 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 48.6. And then I'm going to need to square root that. So 12 squared plus 20 squared minus 2 times 12 times 20 times the cosine of 48.6. I get that, which I square root, a little bit of 15, 15.05. So then this is 15.05, 15.05, and we'll say these are miles. So 15.05 miles from Tower B. First one, done. Second one, how far was the phone from Tower A at 312? So 312 to A. 312 is down here, that's swag, and to A. So I want to find this missing length right there. That's this diagonal. So I'm trying to find this guy. That's my unknown for this one. What information do I have? Angle, side, angle. Hey, I can do law of sines for this one. Nice. So I'll say the sine of what angle side pair do I have? 90.3 over 20 is the sine of 70.5 over x. And now I will cross multiply. And get x is 18.85. So 18.85. 18.85 miles from Tower A. This is 18.85. Describe the location of the phone at 355. 355 is infamous footwear from Tower A. So remember, Tower A is up here. So the location of the phone from Tower A in terms of its angle. So I want this angle then. So to find that angle, can I do law of sines? I think I can do law of sines. But I'm going to have to find this angle and then subtract. Because I don't have this side. I could find that side probably. But it seems like a waste of time. I'm just going to go ahead and find that angle and then I'll subtract from 180. So we'll say the sine of 29.7 over 10 is the sine of theta over 20. Now you need to be careful. Look at the information you have. Angle, side, side. When you are given angle, side, side, you are in trouble. You need to be careful because this is the ambiguous case. So we're going to multiply both sides by 20 times the sine of 29.7. Then I'll divide by 10. And then I will take the inverse sine of that. This is pretty close to 90, huh? 82.3. So this angle is 82.3. Well, maybe. Theta is 82.3. Or it could be its supplement. Because this is the ambiguous case, we have to check to see if it's possible for it to be its supplement. 97.7. If you add 29.7 in there, you have enough room for a third angle. So it could also be 97.7. And the question is, which one is it? And we don't really have a way to notice this, or to answer this question, which one it is. I can kind of eyeball it, and it seems to me that it is obtuse. So I'm pretty sure it's 97.7. But here's what we're going to decide for this whole activity. If you ever have an ambiguous case, the triangle is obtuse. So in this problem, the triangle is obtuse, which means you have to have one angle bigger than 90 degrees. It's that one. Now I can find angle A by subtracting 180 minus 29.7 minus 97.7. And I get 52.6. So this angle is 52.6. Now it says describe it in terms of the angle. So this is going to be kind of weird, but think you would, if you would orient your protractor vertically, we'll call that, we're going to face south. So if I was at tower A, I would want to face south, and then I want to rotate this way. So that's rotating east. So we would say this is 52.6 degrees east of south, because you face south and then you look east. This is 52.6 degrees east of south. Last question just says, describe a possible route for the shopper. I think there's only one route. They went to the dust collectors, and then they went to swag, and then they went to infamous footwear. We have their times. So there's not really a good part to that question. It's just they went to those three places in that order. I mean, you can kind of try and visualize it, but they went here, and then they went there, and then they went there. Okay, that's it. So you're going to do a lot of these tests with your group, and you're going to put all of your answers into Schoology. And once you get that done, your project is done, and that's it for law sines and cosines. So be sure to hit that like and subscribe button.